Okay, so first section we're going to take a look at is 1.3 part 2. And it's kind of a little bit of a review about how we find a window. Okay, so let's try to graph this on the calculator. And then we'll see how high and low the graph goes. That's the range. And then how far left and right it goes. That's the domain. All right, so does anybody remember what button do you press if you want to type in a graph? What's the first thing we have to press? Yep, Francesca?
The y equals.
Yeah, we're going to press the y equals. If you have anything else there, you can clear it out. And we're going to type in 16x minus x cubed. Just like that. Now, a lot of times, just to start it off, we do zoom, and then what zoom do we usually pick as kind of our starting point? Yeah, we usually do zoom 6. That's a standard window of negative 10 to 10 on the x and on the y-axis. So let's do zoom 6. And you guys should get a graph that looks something like that. Is that a good window? What do we think? I see, Ethan, you were shaking your head. How come?
Because you can't see the range.
Yeah, I can't really see how high and low here. I don't really know what's happening. So he specifically said range, which that affects the y values. So I would set the y min and max as higher so we can see more. Let's try like negative 50. Not on the x min though. Let's try negative 50 on the y min. And let's try positive 50 on the y max. All right, let's see how that looks. All right, what do we think? How does that look? How about Matt? What do you think?
Looks way better.
Yeah, that looks better. Yeah, I can see what's happening. I don't know if we went over this yet, but if you look at this highest exponent and you subtract 1 from it, it tells you how many times the graph can turn at most. All right, so we see an exponent of 3. That means this graph could take 2 turns. I can see both turns on the screen. That means nothing else is happening off the screen. So from here, this graph is just going to continue kind of going down and to the right. This is going to continue going up and to the left. So that's, as far as finding a complete graph, I think we've got it. So our window was, I think we did negative 10 to 10. That's your x min, x max. And then do we do negative 50 to 50? Is that what we went with? For the y min and max?
Yes.
Okay. Okay, so find a complete graph, good. Now, domain and range. There's only 2 things you have to be careful about when you're looking at domain. If you don't have a picture, look at your original formula and ask yourself, does it have a square root? Does this original problem have a square root? No. The reason I want to know if it has a square root is because you're not allowed to take the square root of a negative number. But that can never happen here because there is no square root. The other thing you look for when you're looking at the domain is, do you have a fraction with a variable in the bottom? Is there a fraction in this problem with a variable in the bottom?
No.
No. The reason I look for that is because if I have a variable in the bottom, it could be 0. And I don't want to ever divide by 0. So both things that I have to look for aren't in this problem. So what does that mean my domain is? Yeah. It's all real numbers. So we can say it like this, negative infinity to infinity, parentheses. Now, if you weren't sure that way, we can look at the graph and ask ourselves, how far left and right does this graph go? It's going to go left and right forever. Okay? No matter where you look on the screen, it's just going to keep going left and right. Now, how about up and down? How far does the graph go up and down? How about Chris?
That would also be an infinite.
Yeah. If you're not sure, one other thing you can do is just draw like an imaginary horizontal line and drag it up and down. If there's anywhere that that line doesn't hit your graph, then that means the range isn't all real numbers because there's like a gap. But as I drag it, I'm not seeing it miss the graph anywhere. No matter where you put the line, it's going to hit the graph all the time, dragging it up and down. So your range is also the same. Okay. Any questions on that? Okay. All right, so let's look at this problem. This is a word problem, but it's going to help us to make a diagram of it and to kind of visualize it a little better. But it says that we have a rectangular pool, and the dimensions of the pool are 30 feet by 50 feet. And we're going to put a sidewalk all the way around the pool. The sidewalk is going to be the same width, and it's just going to be like a border right around the edge of the pool. They tell us that the area of the sidewalk around the pool is 600 square feet. Knowing the dimensions of the pool and the area of the sidewalk, we want to figure out what the width of the sidewalk is. That's the question. So as I said earlier, this problem really lends itself to drawing a diagram so we can kind of visualize what's happening. So that's the first thing I'll do. We'll make a diagram. And we're basically going to need two rectangles, one for the pool, and then another rectangle around that represents the edges of the sidewalk. So let's start with our pool that's 30 feet by 50 feet. So 50 by 30. I'll put the 50 inside so we can kind of see it better. So there's the pool. And we're going to put a sidewalk around that. That's as good as I can do. It's supposed to be the same width all the way around. Okay, so that is X from there to there. Okay, questions on my diagram? Okay, so now we want to come up with a formula that's going to use the area of the sidewalk. Okay, we want to come up with a formula that's going to use this number. So, does anybody see how we could figure out the area of the sidewalk using these two rectangles? It's my hint. Somehow I want to use the bigger rectangle and the smaller rectangle and get the area of just the sidewalk. Yeah, Haley?
Would it be length times width?
So that's how we're going to find the area of each rectangle. The area of a rectangle is length times width. But how could we figure out just this? Just that shaded part around the edge. Yep, Sarah?
Could you do like, because it says the area of the sidewalk is 600 feet.
Yep, so that's going to end up going over here on the left side.
So could you do like 600 minus the area of the pool?
So I do like the idea of subtracting. Yes, you definitely want to do some subtracting. And what are the two things I could subtract on this side to get the area of the sidewalk? Anyone see? Yep, that's it.
the area of the pool minus the area of the sidewalk?
So the area of the sidewalk is gonna be, we're gonna keep that on this side. We're gonna have two other things on this side that are not the area of the sidewalk. So somehow we have to use the big rectangle and then the small rectangle, which is the pool. Anyone have another guess? Same thing as, what if I had this and I told you to find the area of this shape in here? It's like this, let's say you knew the area of the big circle and the small circle. What could you do? How about Tyler? So if, let's say you knew the area of this big circle, right? Let's say this big circle was 100 square units. This small circle is 15 square units. How could you get this if you knew the big circle was 100 and the small circle was 15? Yeah.
Would you subtract them?
Yeah, what would you subtract?
The 100 minus the 15.
Yeah, you take the bigger circle, take the area of the big circle, which would be this, minus the area of the small circle, which is just that. And if you take the area of the big minus that small circle in the middle, you're left with that on the outside. All right, so we're going to do the same thing here. Take the area of the big rectangle, and we're going to minus the area of the small rectangle, but we're going to call that the pool. Let's fill in what we can. Matt, what's the area of the sidewalk?
600.
Yeah, they tell us now, right? The area of the sidewalk is 600. Right? And earlier someone else said the area formula for a rectangle is length times width. So I'm going to come back to that when we find the area of the pool. What's the area of the pool here? How about Jack?
1,500.
Yeah, 30 times 50. That's 3 times 5 with 2 zeros. So the area of the pool is 1,500. Now I need a formula for the area of the big rectangle. It's still length times width. So we're still going to have length times width. I just need to find the length of the big rectangle. So I don't think they can tell me how long it is from there all the way to there. It's not going to be a number. It is going to have a variable. Well, Zach, do you have a guess how long that is? What if I went like this? Does that help?
Like 50 plus X.
Okay, so that's this and this.
50 plus 2X.
Good. 50 plus 2x. That's the length of the rectangle. And the width, it's the same idea. It's 30 plus x plus x. So 30 plus 2x. There we go. Any questions on that? Okay, so let's do this out and see what we get. 600 equals, Abigail, if I multiply this, what's 50 times 30?
1500.
Yep, 1500. How about, Casey, 50 times 2x? 100x. 30 times 2x, Isaac?
60x.
60x. And 2x times 2x is 4x squared. I have a 1500 and a minus 1500. So those cancel out. And I can combine like terms. So I have 600 equals 160x plus 4x squared. Does anybody remember what kind of equation that is when the highest exponent is a 2? Begins with a Q? Yep.
Is it a quadratic equation?
Yeah, it's a quadratic. So there's a couple different ways we can try to solve it. We can try to factor it. But this one's not going to factor. So does anybody remember the other method you can use to solve a quadratic equation? If it doesn't factor. This method also begins with a Q. Yep.
The quadratic formula?
Yep, it's the quadratic formula. So we're going to have to use the quadratic formula to solve this one. The first step to using the quadratic formula is to get it equal to 0. How about, Chloe, how can I move this 600 over to the other side?
You can subtract.
So we want to put this over there. Right now, is that a positive 600 or a negative 600?
Positive.
Positive. So what would be the opposite of that?
Subtracting.
Subtract. So we're going to subtract 600. We're going to subtract 600 over here. That's gone. And I'm going to write it in order from the highest degree exponent to the lowest. So 4x squared plus 160x minus 600. And then I can divide everything by 1, just to make the numbers a little smaller. Yep, Francesca?
2.
2. We can even go bigger. You can divide by 4. This isn't necessary, but it does make the numbers a little smaller, but it's not going to change the answer. Okay, now we need to use quadratic formula. If you don't remember what that is, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, does anybody remember what's the a, the b, and the c? Where do those come from? Matt?
They come from the equation, so x squared would be a.
Can you say that again?
They come from the quadratic formula, so then a is equal 40x. X squared would be b. I mean, would be a, sorry. X
So the
squared-
a, b, and c all have to be numbers.
So then 1,
1. So yeah, a is 1,
yeah, then 40,
b is 40,
and then negative 150.
and negative 150. So now we fill those in, see what we get, and go from there. So we have negative 40 plus or minus 1600 minus 4ac all over 2a, which in this case a is 1, so it's all over 2. So we've got minus a minus. What happens when we minus a minus? Yep,
Positive.
turns positive, so I can take care of that. We've got negative 40 plus or minus 4 times 1 is 4. 4 times 50 150 is 600. What's 1600 plus 600? Yes?
2,200.
2,200, 2,200. Divided by 2. And now let's plug that in, see what we get. Remember, what am I solving for again? The whole point of this problem was to find what?
The
The width.
The sidewalk.
The width of the sidewalk. So when you're thinking about a length, because width is a length, what kind of number doesn't make sense for length? Yeah?
Negative number.
Right, negative number. We don't want a negative. So it doesn't make sense for me to do negative 40 minus the square root of 2,200 because that's a negative number minus a number. That's even more negative. Divided by 2 is still negative. So I'm only really worried about the positive here. Okay, not the negative. So let's do negative 40 plus the square root of 2,200. That's just the numerator. Divided by 2. And that is the width of the sidewalk. We'll round it to 2 decimals, 3.45 feet. Okay. And that's an example of solving a quadratic using the quadratic formula. We're going to solve another quadratic in the next problem, but I'm going to show you how to do that one on the calculator. All right, any question on that? So when I started the problem, I really had no idea it was going to be a quadratic. It's just when I drew the picture and started doing length times width, it's just how it worked out. A lot of times we don't really know what's going to be involved until you get that diagram set up and go from there. All right, so the last thing in, or second to last thing in this part is what's called projectile motion. And I'm going to use this to show you guys how to solve a quadratic without the quadratic formula. Okay, we're going to do it on the calculator. This formula tells you how high an object will travel based on a few different things. So it's like you're taking an object and you're throwing it. That's what this models. How high the object is, first of all, it depends on how long has it been in the air for. Okay. How much time has it had to start going up? The second thing it depends on is how fast did you throw it. Okay, the second that the object left your hand or the second the object was fired, how fast was it going? And the third thing that affects how high it's going to go is how high did it start off the ground? Did you throw this object off a building that was already 400 feet tall, so the object was already 400 feet in the air when you threw it, and it's going to go all the way down to the ground? Or was it something that was shot from ground level? Maybe it was a rocket on the ground. You press a button and then it takes off, but it started on the ground. So that makes a difference. This particular formula uses the number -16, and because it uses that number, that means we have to use units of feet and seconds. If you do this in physics, if anyone takes physics, you might see the number -9.8 right there, and that's because they're using meters per second. It has to be gravity. Okay, but there's your formula for projectile motion. So, I'm going to give you a word problem, and we're going to try to fill that formula in with all the information they give us. And I will scroll back up to it as we read the problem. So, it says a model rocket is shot straight up from ground level with an initial velocity of 64 feet per second. Oh, let's fill all that into our equation. So, we've got S of t, that is my height. And the height is calculated by what goes on the other side. What's the first number that was in the equation? Yep.
-16t squared.
So -16t squared, that never changes. Plus v sub 0 t. Initial velocity times time. What's my initial velocity in this one? Yeah, Chris?
64 feet per second.
64 feet per second. You put a t. And the last thing you put, plus initial height. What do you think my initial height is in this problem? Yeah.
0.
0. What tells you that?
It's at ground level.
Ground level. It was on the ground when it was fired. So ground level, so I don't even need to put plus 0. There's my equation. And remember, this box right there is the height. So you tell me what time you want to know, maybe 2.5 seconds. I could plug 2.5 in for t, do the math, and I would know how high the rocket is at 2.5 seconds. So it says, at what time will the rocket be 50 feet off the ground? So think about where you would fill in the 50 feet. Would that get filled in for S of t on the left or t on the right? Yep, Sarah?
S of t.
Yeah, S of t. They're giving me a height. They're saying, when is the height 50? We're going to set that equal to negative 16 t squared plus 64t. That's kind of like the area of my sidewalk. That's the number that's on the other side. Now, you could solve this problem exactly the way we did the area of the sidewalk. You could divide everything by 2, just to make the numbers smaller first, and then plug a, b, and c into the quadratic formula after you get it equal to 0. But let's try this a little different. So let's go to the calculator. Let's press y equals. And we're going to do 2 graphs. I want you to put in 50 on y1. And then down on y2, I want you to put in negative 16 x squared plus 64 x. What is y1 going to look like? Y equals 50. What kind of graph is that? Y equals 50. Yeah,
A horizontal line on 50.
exactly. It's a horizontal line at 50. And the reason I ask that is because I'm going to look at my window. Y max is right at 50. That means the line would be right on the edge of the screen. So let's set our Y max at, we could try like 75. Y min. Okay, remember, Y represents your height. What's the lowest height that I could have in this problem? Yep.
0.
0. Doesn't make sense to go that underground. X is time. What's the lowest time I could have? Negative 10 doesn't make sense. Couldn't go any lower than what? Yep.
0.
Can't go any lower than 0. What's my X max? I don't know. That's how long the object is in the air for. If I don't set it high enough, the graph's going to go off the screen. Let's try it at 10 and see what happens. Well, actually, yeah, let's just try it. So there's my horizontal line at 50. So how many times does this object hit a height of 50 feet? Yeah, really? How can it hit twice?
It goes up and then comes back down.
Right, it's going to hit 50 feet on the way up, and then it's going to go higher, and then it's going to come back down through 50 feet again. So it will hit twice. And these two intersections come, if you did the quadratic formula, from the plus or minus. That's why there's 2. And in this case, you would want them both. In the sidewalk problem, we only wanted 1. Does anybody remember how we find out where these lines cross? using the calculator? Yep,
Isn't it calc?
yep, second, calc, and then which option?
Intersection.
Yep, we're gonna do intersect. Remember, you have to tell it which two things you wanna find, which two curves you're using. We're using the blue one. And we're using the red one. I'm just trying to get my cursor on the screen. And it asks me for a guess. Is the guess important? It is, because there's two. So whichever one I'm closer to, it's gonna tell me that one first. So the first one it says is 2.94. That's on the way back down. So T is about 2.94. Let's call that T2 because it's the second time. And T1, second calc intersect. Again, I'll just move closer to the other side. Do my guess. And now I get 1.06. So it will hit 50 feet at both of these times. Any question on how we solved it that time instead of quadratic formula? What? And the last question they ask is, what's the maximum height and at what time do we reach it? So we don't care about this 50 anymore. That was the other part. What is the maximum height and when do we reach it? Well, we know it's higher than 50. It definitely goes above 50. If I do second calc, anybody have a guess which option I'm going to use this time to answer part B? Yep. Maximum. So we're going to do option 4. And you may have to move your cursor a little bit to get it on the screen. Mine was off the screen. So we're going to pick a point that we know is somewhere to the left of the maximum. We're going to hit enter. Then we're going to go to the right of the maximum. Hit enter. And then the guess doesn't matter. We're just going to hit enter. But your screen should look like this before you do the guess. So these dotted lines tell it where to look for a maximum. And then we'll hit enter. And it tells us that the maximum is right there. So the highest this object goes is 64 feet. When does it hit 64 feet? At about what time? Yeah,
2 seconds.
it's 2 seconds. It is 2 seconds. So it hits 64 feet at 2 seconds. So there's a problem. Once you get the initial algebra set up, we use the calculator to do the whole thing. No quadratic formula on that. Okay, any questions on anything we did for that problem? All right, so the last thing in this part is graphing what's called a piecewise function. So it's more of something you have to learn how to type in on the calculator. Basically, what a piecewise function is it's two graphs on the screen at the same time. That's all it is. Two graphs on the screen, same time. And what you basically do is you say, okay, well, for certain values of x, you're going to use this formula. For other values of x, you're going to use this formula. And you might wonder, well, when would you do that? Well, let's say that under 18 had a certain price for tickets, and over 18 had a different price. So if x is less than 18, you're going to use this formula to calculate the cost for the tickets. If X is greater than 18, you're going to use a different formula. In 18, that was just arbitrary. I could pick anything. The point is you use this formula when X is below a certain value. You use this formula when X is above a certain value. Right, and here's our example. So usually the way you see a piecewise function written is it has this kind of curly bracket. And I wrote several parts here, but we're usually just going to have two. And the two formulas we're going to graph are 3 minus x squared, but we're only going to apply that formula to values less than 1. And then to values greater than or equal to 1, we're going to apply x cubed minus 4x. So now if you gave me a value to plug in, let's say you said 5, I have to think which one to use. I say, okay, 5, no, 5 is not less than 1. 5 is greater than or equal to 1. Okay, I'd use the bottom. So let me show you how you type this in. So the first thing we have to do is put this in parentheses. 3 minus x squared. Okay, so don't just type it like you normally would, but put it in parentheses. 3 minus x squared. That's step 1. The next step is in parentheses, right next to it, type in x is less than 1. And I'll show you how you type less than. So first you're going to press X. And then to get the less than button, you're going to press second, math. If you press second, math, it'll bring up this menu you see on the screen. And you get a less than right there. Mine is number 5. Now we'll go down to Y2. We're going to type in parentheses x cubed. Now, when I type cubed, my cursor is still blinking up in the exponent. I'm done in the exponent. I don't want to be in the exponent for the minus 4x. Press the right arrow, and it'll drop you back down to the normal arrow. So it should look just like that. X cubed minus 4x. And this time it's x greater than or equal to 1. So x second, test, greater than or equal to 1. Now, the calculator likes to draw something everywhere, even when we tell it not to. So this top one, we told it, only draw this when you are less than 1. Well, the calculator is still going to try to draw something when it's greater than 1. So what it's going to do is put a flat line in, even though we don't want it to do that. So I'll show you what we need to ignore in the picture. So for the graph in blue, ignore, oops, I don't know why I hit 5. I meant to hit 1. Oh, I think it was option 5, and that's why I got confused. So for the graph in blue, we're going to ignore everything past 1. Whatever it does past 1, don't even pay attention to it. So here's our graph. Let's do zoom 6. Okay, that's good, we want it. Okay, ignore all that flat line. Same with this, ignore all that red stuff. Now that's what we want to look at. So let's kind of clean that up a little bit. We're going to pretend like we can't even see that red and blue stuff right on the axis. So let's just put that just like that. Now, look at the blue. This was the blue. This was the red. Let's put like a little box next to it. for the graph in blue, does it include 1 or does it not include 1? It doesn't include 1. What kind of symbol do we use when it does not include something? Think about like on a number line. In your graph. Yep. Open circle. So technically, we should have an open circle on the end of that blue one because we cannot include 1. How about on the graph in red? Does that include or not include 1? Well, Deb?
Yes.
Yes. Yes, what?
Yes, it does include 1.
Yeah, it does include it. So what kind of symbol do we use for that?
Closer.
Closer. Can't do that on the calculator, but that's what the graph should really look like. Now, why can't I do this? That's a pretty big problem. How come? People see what I did? We had that. I made it that. What's wrong with it? Yeah.
Isn't it saying that 1 is included in that line?
And what's wrong with including 1 in the blue one?
Because it's not. Because it's an open circle.
Well, let's say I made it a closed circle. What's wrong with doing that? Yep.
It's in both rules.
It's in both rules. That's not good. When you're writing a piecewise function, any value that you put into it should only fit in one spot. If it fits in both, then that's wrong. Okay? It's either this or that. It can't fit in both. Okay? So that's why they had to do it that way. All right. So any question on graphing a piecewise function? I think as far as new stuff today, that's all that you'll see that's new. The last thing we're going to review a little bit is like y equals mx plus b, slope, y-intercept, that kind of basic stuff. Okay, but I think some of this might have been new, especially the graph calculator. All right. Does anybody remember from Algebra 1, what's the slope-intercept form of a line? It starts out y equals. And it usually uses certain letters. Yeah.
Y equals mx plus b.
Yep. Do you remember what the m stands for? In that formula?
Slope.
Yep, m is your slope. Anybody remember what the b stands for, Chris?
It's the base.
It actually doesn't stand for anything with a b in it. Yeah. Yep. A good guess.
Y-intercept.
It's your y-intercept. So m is your slope, and b is your y-intercept. And that's generally how we write linear functions. Like you have quadratic functions, we usually write those ax squared plus bx plus c. This is how you generally write a linear function. Slope-intercept is the most common way. There are two other ways. There's point-slope and there's general form. We don't use those as much, but we'll touch on them quickly. So linear functions are generally written in the form y equals mx plus b. Any question on that? Again, I think this whole part's going to be reviewed, so we're not going to spend as much time on it. All right. All right, so slope. How do you find slope? There's a formula that sometimes we use, like both words begin with an R. Anyone remember the two words I'm thinking of? Ashley?
Rise over run.
Yep, you can think of it as rise over run. And the way you calculate rise is you subtract the y's. Rise, rise. Find the rise, subtract the y's. So rise is vertical distance. Run is horizontal distance. So generally when you're trying to find slope, you have to be given two coordinates. And you take the vertical distance between the points and you divide by the horizontal distance between the points. And that's the formula for slope. Now there are two special cases of slope. There's a line that's perfectly horizontal, and then there's one that's vertical. Does anybody remember the slope of a horizontal line? What is that? Yep, Sarah?
0.
It's 0. Horizontal line, again, kind of a special case, has a slope of 0. How about vertical? Yeah?
They're like undefined.
Undefined. And these two lines cannot be written really in y equals mx plus b because they're special cases. Horizontal line, I think it was Tyler, I asked him earlier, what does y equals 50 look like? And he said y equals 50 was a horizontal line at 50. So horizontal line is just y equals a number. Vertical line is x equals a number. We can't do vertical lines on the graphing calculator. Can't do it. Yep, those are two special cases of slope. So let's see if we can find the equation of the horizontal and vertical line that would go right through those points.
Sure,
I just have a sport dismissal.
Okay, yeah, just sign out and all that.
that's my water something.
Definitely.
Yes. Yep.
You just got it.
So here's a coordinate. It's got an x and a y value. And if you want to visualize it, it's the point 2, 3. Right there. I want to know the equation of the, let's start with horizontal line. That's y equals. The horizontal line that would go right through the point 2, 3. Anybody tell me what the equation of that dotted line would be? Yep, Chris.
Y equals 3.
Y equals 3. Now, next thing I want to know is the equation of that line in red. What would be the equation of the line that goes through the point 2, 3, and it's vertical? Vertical line through the point 2, 3, that red line, basically. Yep, Ethan?
X equals 2.
X equals 2. Again, not y equals mx plus b, but those are special cases. And actually, I already told you guys that on the previous page. Any question on that? All right. So sometimes you're given an equation that's not in y equals mx plus b, and you want it in y equals mx plus b. You just can't make it. So we have to get the y by itself. So let's just see if we can do that, and then talk about, well, why would you do that? What would be your first step here to get that by itself? Yeah.
Subtract 2x from both sides.
Good. Subtract 2x from both sides. And that would leave you with 3y equals negative 2x plus 6. And what would be your final step to get y by itself? Yeah.
Divide by 3.
Yep. Divide by 3. 3, 3, and 3. And we got to do it in all those spots. So we end up with y equals negative 2/3 x plus 2. What's the advantage of having it like that? I mean, it means the same thing. But what's the advantage of this? About Abigail? Can you tell me why this maybe we like better than what we started with?
It's easier to graph.
Yeah, it's much easier to graph because you can see your y-intercept. And from that y-intercept, we have a rise and a run. So if I was going to graph this, I would start at a y-intercept of 2, and I'd go down 2, right through. And that would give me a nice graph. That's why we do that sometimes. So I told you slope-intercept form is the way we do use most often. But there is something called point slope. This is good if you have to find the equation of a line and they tell you a point and a slope. You don't have to do it this way, but I think this way is easier than y equals mx plus b for certain situations. So it's just an alternate way to write the equation of a line. All right, so let's try using this formula. I'll give you a couple pieces of information and see if we can get the equation of a line. The two things I have to tell you are a point and a slope. Those are the like two things I'm going to tell you. You don't need a y-intercept for this. So let's find the equation of the line with a slope of a half, and it's going to pass through the point -2, -3. So Isaac, that 1/2 is going to be plugged in for what letter?
M.
Yep, good. That's my M. How about the -2? Chloe, what's the -2 going to get plugged in for?
X.
Yep, x1. And Matt, what about the 3? Y1. Okay, let's fill those in. So we're going to have y minus y1 equals, Casey, what's going to come right after my equal sign?
Probably 100.
Yep, good. M, 1/2. And Ethan, what's going to go in parentheses right there?
X minus 2.
Say it again.
Wait, X plus 2.
X plus 2. It's x minus x1. X minus -2. And that is point slope form. Now, if we didn't want it in point slope form, you could do the same thing here that we just did here. You could get y by itself. You'd have to distribute out the 1/2 and then add 3, and you'd be done. Okay, but I'm going to leave that in point slope because it didn't say I couldn't. So let's just leave it like that. Any question on it? Okay, parallel and perpendicular lines. If two lines are parallel, what do we know about them? Actually, they have something that's the same and something that's different. What's the same? Yeah,
Same stuff.
same slope, and different, yeah,
Y-intercept.
y-intercept. Can't be same slope, same intercept, then it's same line. That's not parallel. But parallel lines have the same slope, different y-intercepts. Maybe something like this. And how about perpendicular? That one's a little tricky. Does anybody remember if two lines are perpendicular, what the slopes are? So you need two words to explain it. Sarah?
Well, I don't know what the words are, but they have like an opposite.
They are opposite. That's part of it. And Ethan?
The reciprocal.
Reciprocals. Yep. So an example of opposite reciprocals. What's the opposite reciprocal of 2/3? Yep.
Negative 3 over 2.
-3/2. Good. And then that's the last thing. So what you'll see on a problem like this is something like find a line parallel to the following line and goes through a certain point. So it's almost like a problem like this. The only difference is they don't tell you that. You have to find that. But they will tell you a point. So it says write an equation that is parallel to this. So we want to be parallel to that. And we want to go through that. So we've got the point. That's like the x1, y1. How am I going to get the slope of 3x minus 2y equals 1? What did I recommend earlier you do to make it easier to see the slope? Because it's there, it's just not easy to see. Yep, Ashley?
And slope intercept form.
Yeah, let's rewrite that in slope-intercept form. 3x minus 2y equals 1. I would minus the 3x. So you have that. And Zach, what would be my last step? Oops. Messed that up a little bit. What would be my last step to get y by itself?
Divide by -2.
Good. Divide by -2. So I don't even really need to keep going. I just need my slope. And at this point, I have it. What's my slope? Chris?
-1.5.
So let's leave it as rise over run. Can you leave it as an improper fraction?
-3 over 2. -3 over -2.
Which is? Yep.
3 over 2.
3/2. Yep. That's the slope you want to use. So now you've got a point and a slope. It's just like the example we did 2 problems ago. You plug in your point and your slope. I'll just do it quick. Y plus 2 equals m times x minus 1. Okay, didn't see anything about getting it in y equals mx plus b, so I'm going to leave it like that. And if they wanted perpendicular, I would have only changed one thing. I would have changed that number 3/2 to -2/3. It's the only change. All right. Any questions before we finish up? All right. So the last thing is graphing a linear inequality. You guys remember kind of doing stuff like this? Draw a line and then shading above and below. So, to graph a linear inequality, the first step is graph the line they give you. Now you have two options for the kind of line. You either can have a solid line or a dashed line. Which line you use depends on what inequality symbol is in the problem. If you have a less than or a greater than, that's a dashed line. If you have a less than or equal to, greater than or equal to, that's a solid line. Okay, so this is kind of like a table. Then, once you know what kind of line to put, you have to decide if you should be shading above or below. Less than, think less than is less is below. If I have less money than you, my amount of money is below your amount of money, below. Less than is below, greater than is above. And I think that's pretty much it for the steps. That little chart kind of summarizes it very, very nicely. So we'll finish up with one example of that, and that'll be it. Don't worry about how you do this on a calculator. You can do shading on a calculator. We're not really going to get into it. Don't worry about that. Okay. So I like to graph it in y equals mx plus b. You don't have to do it that way. But that's how I'm going to try to do it. And let's change one of these numbers so it actually comes out a little nicer. Let's make this 3 also a 2. Purely so I don't get fractions, so I don't have to graph decimals. Okay. How about Tyler? Can you tell me my first step to get y by itself?
Subtract 2x.
Good, I like it. Subtract 2x. And my last. Francesca?
5,
Good, 5?
2.
By 2. I shouldn't assume that people remember this, but does anybody remember the rule? If you divide both sides of an inequality by a negative, what happens? We're not doing it here. But what's the rule if you divide by a negative? Yeah?
The sign flips.
The sign flips. Okay, again, we divided by a 2, so you don't have to worry about it. Y is less than negative x plus 2. What's my slope here? If I want to think about it as rise over run, what number can I put in front of x? Yep, Sarah? 1. And what about in the bottom? If I want to put something. 1. Okay. Matt, what's my y-intercept? 2. And my slope? Down 1, right 1. Top number tells you up or down. The bottom number is always to the right. That's how I remember. Down 1, right 1. Down 1, right 1. You can do that as many times as you want. I mean, you could go the other way too. However you remember it. You don't need that many points. I'm just showing you the whole thing. Solid line or dotted? Yep, Ethan?
Dotted.
Dotted, because this is a less than symbol. So I basically already have a dotted line. Go like that. And lastly, shade above or shade below? Yeah.
Above.
How come?
Because it's less than.
Because it's a less than?
Oh, below. I wrote that wrong.
less than, shade below. And it doesn't have to be perfect, you know, just kind of, that's good enough. All right. So I know there was a lot of stuff in 1.4, but I'm hoping most of that, like y equals mx plus b and slope stuff, was review. But maybe not the calculator stuff we did before. Cool. Any questions? All right, so we've got about 8 or 9 minutes left. I'll put up the homework. So the first 8 or 9 problems on page 31, that's what we did first on the finding the window, we did quadratic formula problem, that kind of stuff. And then the last set of problems, that's on slope, y-intercept, and that kind of stuff, page 42. Remember that if a question says find the complete window, there might not be anything you have to write down other than the x-min, the x-max, the y-min, and the y-max. Okay, so there are some questions that are purely stuff you're just going to practice on the calculator.